Hey y'all, in this video we are going to go over questions 11 and 12 from your study guide. For these we're going to have tension problems where we have a box hanging by a few ropes and the boxes are at rest, and we're going to determine some missing information about it. So for this first one, number 11, we have a box hanging by ropes A and B. Rope A is at a 50-degree angle, rope B is at a 35-degree angle. We want to find the weight of the box, the mass of the box, and the tension in rope A. So to do this, we're going to use some trig functions. Think of this as a vector problem, right? For this, we're given the tension in rope B is 150 newtons. So we can go ahead and write that here. And that's the tension that the rope is pulling up in this direction. Ultimately, though, we don't care about this tension. We want to find how much of this rope is pulling it over in the x direction. We're going to call this xb. And then how much of that rope is causing it to pull up, and we're going to call that YB because it's pulling up in the Y direction. And we can break this down using sine and cosine to do it. For XB, that is the adjacent side to our 35-degree angle, so we're going to use cosine. So it's going to be our hypotenuse of 150 newtons times cosine of our angle of 35 degrees. We're going to multiply that out, and we get an answer of 122.9 newtons for XB. Then we're going to go ahead and work out YB while we're here, and that's going to be kind of the same thing, but this time we're using sine, so 150 newtons times sine of 35, and that is going to equal 86.04 newtons when we work that out. So this rope B is pulling it over 122.9 newtons, and it's pulling it up 86.04 newtons. Right? So now we can look over to rope A, and we know that, think of this as like a tug of war. The same amount that B is pulling in the x direction, A needs to match it. So this x direction, so we're going to call it AX, it's going to match what B is pulling in that direction. So this is also going to be 122.9 newtons. All right, the Y's will not match. They can pull up by different amounts because that Y total is going to balance out with the force of gravity or the weight of the box, because that's what's pulling it down. So it's like whatever the Y total is, the Y up is going to match the Y down. So we'll come back to the Y's. Well, we're going to go ahead and find this value of for rope A here. So rope A is pulling up here by this 50-degree angle. So we're pulling again by XA over, we've already figured that out. And we're pulling up by YA. So we want to find these values. So let's go ahead and find the value for A. So that is our hypotenuse. So it's a same deal. You're going to use sine and cosine. Our XA is equal to your hypotenuse, which is A, times cosine 50 degrees. So we know XA is 122.9 newtons. We don't know what A is yet, our hypotenuse, but it's multiplied by cosine 50. So then we can divide by cosine 50 to solve for just A. And then that is going to equal, in the calculator, is going to equal, that is going to equal 191.2 newtons for A. So 191.2 newtons. And that is our tension in rope A. All right, moving on, we can find the weight and the mass of the box, we're going to need to know this value for YA. So now we have our hypotenuse of A. So now we can find YB by doing A sine 50. So we have 191.2 times sine 50 will get us YB. And when we type that in the calculator, we're going to get an answer of 146.5 newtons. And that is the value for YB here. Right? So now we ultimately want to add our two Y's together. So we're going to add YA and YB together because that's the total value of Y. And that's going to equal with our weight of our box. So YA was 146.5 newtons plus YB was 86.04 newtons. And we're going to add those together. And that's going to equal 232.5 newtons. And that is the total that those ropes are pulling it up by. So this one's pulling it a little bit up, this one's pulling it up, in total it's that many newtons up. So that's going to equal with the weight of our box. So we can find the weight of the box now is 232.5 newtons. And the last thing we want to find is the mass. Same thing as we've always been doing. Force of gravity is mass times acceleration due to gravity. So the weight is your force of gravity is 232.5 newtons. Your mass is what we're solving for, and g is 9.8 meters per second squared. So then we divide 232.5 divided by 9.8. It's going to equal about 23.7 kilograms. And that is the mass of the box. And we are done with number 11. So now let's move on to the next one. So number 12, similar kind of process here. We've got a box hanging by two ropes again, but this time A is going completely horizontal and B is at the angle, and we don't know what the angle is. There is a typo in this question, of course there is. I'm asking you for the tension in rope A, but I gave it to you. I actually wanted to know the tension in rope B here. So for this one, we're given the mass of the box is 25 kilograms. We can go ahead and figure out the force of gravity that's pulling this down by multiplying this by 9.8 meters per second squared. That's always a good first step, and that's going to equal 245 newtons. And then the other piece of information that was given to us was rope A is 200 newtons, so that's pulling this way 200 newtons. And then we have rope B, which we want to find stuff about. So for rope B, this rope is pulling at an angle of some sort. And so some of that tension is pulling it to the right, and some of it is going to be pulling it up. So we're going to call this X, and we're going to call this Y for side B. So for the X direction, it needs to match what A was pulling. So this is going to match and be 200 newtons. And then the B needs to match, the YB needs to match the vertical. So we only have the force of gravity pulling it down, and rope A is not doing any work to pull this box up. So that's going to have to match and be 245 newtons. So now those are those values. Now you can use Pythagorean theorem or trig functions and find out the rest. So to find the value for the tension in rope B, you can do it two ways. You can either use a trig function once you know your angle, or you can use Pythagorean theorem. So 200 squared plus 245 squared will equal B squared. And then when you work all of that out, Pythagorean theorem, you're going to get about 316.27 newtons. And you can do it that way. So that's the tension in rope B is 116.27 newtons. Then to find your angle in the rope, we're looking for this angle. So we're going to use an inverse trig function. You technically, after you solve for this 316, have all sides of your triangle. So you can use any of the trig functions since you know all three sides now. I personally just always stick to inverse tan. That's my favorite. So inverse tan of your opposite side of 245 divided by your adjacent side of 200 will give you that missing angle. And so when you do that, you are going to get an answer of 50.77 degrees for your angle. And that would be the angle that B makes in order for this to work. And now you are done.